Okay, 3.4 notes, taking the derivative of the inverse of trig functions. So it says, quote from the AP exam, notation, the inverse of trigonometric function x may be indicated using the inverse function notation f to the negative 1 or the prefix arc, which means we could say the inverse of sine x or we could say arc sine of x. Okay, so you could see it two different ways in these examples. Okay, so for these ones here, I know I've asked you guys to memorize a lot. Well, there's a little bit more we need to memorize, and those are going to be these inverse trig derivatives. Okay, so I would memorize. Okay, so the derivative of the inverse of sine is equal to 1 over the square root of 1 minus x squared. The derivative of the inverse of secant is 1 over the absolute value of x times the square root of x squared minus 1. The derivative of the inverse of tangent is 1 over 1 plus x squared. The derivative of the inverse of cosine is negative 1 over the square root of 1 minus x squared. The derivative of the inverse of cosecant is negative 1 over the absolute value of x times the square root of x squared minus 1. And the derivative of the inverse of cotangent is negative 1 over 1 plus x squared. Okay. Notice that the derivative of the inverse of sine and the derivative of the inverse of cosine are the same, except cosine has a negative. Okay. The derivative of the inverse of secant and the derivative of the inverse of cosecant are the same, except for that negative. And then same with the inverse of tangent and the inverse of cotangent. So honestly, if you just memorize these ones, and then remember that if it starts with the C, cosine, cosecant, or cotangent, it's going to have a negative in the front. Okay. So first example here, it says find the derivative of the inverse of sine of 3 of x. Well, based off of the definition, we are going to use 1 over the square root of 1 minus x squared, which is 1 over the square root of 1 minus 3x squared. And then since we have 3x as our x value, we have to multiply by the derivative of 3x based off of the chain rule. So this is actually going to be multiplied by 3, which means we have 3 over the square root of 1 minus 9x squared. Okay, number 2 is taking the derivative of the inverse of tangent of 2x squared. So we know we're using 1 over 1 plus x squared. Well, in this case, x is 2x squared. So this is equal to 1 over 1 plus 2x squared times 4x. Because then we have to take the derivative of what that x value is based off of the chain rule. So really, we have 4x over 1 plus 4x to the 4th. And then example 3, remember if we see arc secant, that's the same as saying the inverse of secant. So we're taking the derivative of the inverse of secant, which is 1 over the absolute value of x times the square root of x squared minus 1. In this case, x is 5x, so it's 1 over the absolute value of 5x times the square root of 5x squared minus 1 times 5 because of the chain rule. So then this gives us 5 over 5x times the square root of 25x squared minus 1. Okay. Now in the next example, it wants us to simplify the inverse of secant x, or let me rephrase that. It wants us to simplify the derivative of inverse secant x. So here it gives us the derivative and it wants us to see if we can simplify it. Well, this 9x squared and 3x to the third power could end up simplifying because we can change this to be 3x squared times the absolute value of x, which means that 9x squared and 3x squared can cancel and we're left with just the 3 on the top, which means our answer would be 3 over the absolute value of x times the square root of 9x squared minus 1. 9x to the 6 minus 1. Same with number 5. We could get rid of this and translate that to 2x times the absolute value of x. And again, we're trying to get that absolute value of x because if you remember, the derivative of the inverse of secant has that absolute value of x there. So we're just factoring that out so we have that left over. Okay, when we do that, we could cancel out this 2x with this 4x and we'd be left with 2, which means we now have 2 over the absolute value of x times the square root of 4x squared minus 1. Okay, now it says the domain of the inverse trig functions. So for each of these inverse trig functions, you have to know the domain of each in order to answer and evaluate certain functions, okay, certain inverses of trig functions, okay. So for here, the inverse of sine, the domain is -1 to 1, and the range is -π/2 to π/2. To make it easy on yourself, you can recall that these values here on the unit circle can be translated to the following. So 3π/2 can be -π/2. 5π to the third could be -π/3. 7π to the fourth could be -π to the fourth. And then 11π to the 6 can be written as -π to the 6. Okay. The inverse of cosine, the domain is still -1 to 1, and the range now is from 0 to π. Okay. We don't have to change anything because these values here are still within π. Okay. And then lastly, we have the domain of the inverse tangent function, which the domain is between -infinity and +infinity, and the range is between -π/2 and +π/2, which again, doing the same thing, we could translate these just like we did on the inverse of sine. So this is -π/2, -π/3, -π/4, and -π/6. Okay, so then looking at the following example, it says evaluate each function at the given x value. So it wants us to take f of x is equal to arc sine of x at x is equal to the square root of 3 over 2. Okay, so it just wants us to evaluate this function at square root of 3 over 2. Well, we know, based off of the unit circle, that the square root of 3 over 2 is going to be somewhere over here. Okay, so that means f of the square root of 3 over 2 is going to be equal to arc sine of the square root of 3 over 2, which will be equal to π/3. Okay, number 7 says f of x is equal to the inverse of cosine at x over 4 at x is equal to -2. Again, remembering our unit circle, that means we are going to be looking right over here for pi fourths. So that means f of -2 is going to be equal to cosine -1 to the -2 over 4, which means this is the inverse of cosine to -1/2, which would be 2 pi thirds. And then lastly, number 8, we have f of x is equal to arctangent x. Well, again, recalling the unit circle, it's going to be around over here. So we know that f of 1 over the square root of 3 is equal to arctangent of 1 over the square root of 3, which is going to give us pi 6. Okay. Remember, you could also rationalize 1 over the square root of 3 to be square root of 3 over 3. If that makes that easier for finding that pi 6 on the unit circle.